Hello, my name is Zach Thomas, coming to you from Chapel Hill, North Carolina. I lead the Cloud SRE team at Genesys, where we're creating the world's best cloud-native contact center as a service. I will admit that we don't currently have the smallest possible SRE team, but it wasn't very long ago that we did, and we're still quite small. If you're watching this, maybe you want to get an SRE initiative off the ground, but you have to start somewhere, and maybe it's only you for now. This talk is about doing a lot with a little. There's this story about Archimedes, smart guy, Greek, around 240 BCE. He said, "I bet I can pull this ship fully loaded with cargo up onto the beach all by myself." And everyone was like, no, you can't. It's obviously too big and heavy for any one person to do that. And of course, he succeeded because he had block and tackle. By the way, he didn't invent that. It first appeared in Greece about 150 years before then, but he perfected it. According to the legend, he further dunked on all the skeptics by remaining seated while he performed this feat. This is a great example of the principle of mechanical advantage. And I wanted to do a talk about how we gain mechanical advantage in SRE. In the 21st century, we have computation and packet switched networks, and we derive incredible advantage from those, which I'll talk about more in a bit. But as I was thinking about these ancient simple machines, I realized that there are much older tools that are just as valuable today as they ever were. The very oldest is cooperation. And after that, languages and systems of writing, which let you have cooperation over distance and time. I realize this might sound super obvious and cheesy, but this is very much relevant to trying to do SRE with the smallest possible team, because take a look at what the job entails. Capacity planning, architecting for resilience, observability, alerting, on-call rotations, post-incident reviews, operability, disaster recovery, tools, vendor management, chaos engineering, playbooks, road mapping, onboarding and training, service level objectives, diagnosis and repair, elasticity. That's not even a complete list. The point is, it's a lot. You literally cannot do all of this. You will have a hand in all of it, but the job is essentially about how you engage with the rest of the organization so that they can take ownership of these things and build up their own operational excellence. By the way, if you're the kind of person who needs to devote yourself to one thing and focus on it until it's done, you may not want to try this. There are two themes of this talk. The first is that being a leader of SRE is a people thing. Even though we think of this as a technology job, in fact, our systems are complex social and technological hybrids. We can only have reliable systems because when the unpredictable things happen, human beings are adaptable and creative. The second theme is that our best tools for leverage are old and humble. Before I talk about the people things and the tools for leverage, I want to first describe the structure of this tiny team and why we can't learn the structure from Google SRE. The Google SRE book was hugely influential, and it still is. Frankly, I'm amazed that this came out only 4.5 years ago, because we've seen so much exciting work since then. But when anybody recommends this book, and I do recommend it, it usually comes with a caveat, and it's printed right on the cover: how Google runs production systems. It's not a problem for Google that there's only one Google, but it might be a problem for the rest of us trying to figure out which practices to adopt for our own organizations, which are going to be different, of course. At Genesys, we knew we weren't going to run things the Google way. And here's what I see as the fundamental difference. We have no operations teams, at least on the cloud side, which is where I work. We have application development teams, and the developers are also the operators. Genesys Cloud has no network operations center and no follow the sun on call rotation. The way I see it, Google's model is about how to bring software engineering to operations, whereas our challenge is to bring operations to software engineering. And I think this is quite a natural way to do things. If you're building something new, you're definitely going to need software engineering before operations. Your proof of concept is probably running on your laptop or on a disused PC tower under your desk. When you get to the point where you need operational sophistication, that's a really good problem to have, because it means you've made something that a lot of people really need or want. If your situation is like ours, and you have a number of dev teams that need to grow their operational capacity, you need a team structure that supports this. This is Team Topologies by Matthew Skelton and Manuel Pais. I highly recommend you read this one. It explores the implications of Conway's law, which way back in 1968 said, organizations which design systems are constrained to produce designs which are copies of the communication structures of these organizations. It means that the way you organize your teams influences the architecture of the systems you build. Probably the best known example of this is using small, cross-functional, autonomous teams to implement a microservices architecture. Amazon popularized this as the so-called two-pizza team. We're big fans of microservices at Genesys. I believe the organizational benefits are more significant than the technological benefits. Our small autonomous teams can be more productive and can adapt quickly to changes in the business environment. But there is a trade-off between autonomy and the leverage that you get from centralizing things, from shared resources like libraries and infrastructure. Essentially, the problem is that autonomy is good, but every team creating their own deployment infrastructure is wasteful and needlessly complex. In the book, they describe that you need other kinds of teams to help your service teams get all the support that they need. And they identify 4 types of teams. First, they call it the stream-aligned team, which is a strange name if you're not into value streams. But if you're doing microservices, this means service teams. 2, platform team. This kind of team provides facilities that the service teams can use. Everything from deployments to encryption key management to log aggregation. The platform team solves the problem that you don't want every dev team to invent their own infrastructure. 3, the complex subsystem team. This addresses the fact that some pieces of your infrastructure are complicated enough that they need their own care and feeding. So this could be something like your Kafka brokers or an analytics platform. And number 4 is the enabling team. And this is where SRE comes in. These teams function as internal consultants, providing guidance and specialized knowledge when and where they're needed. Enabling teams work for any kind of cross-cutting concern. So this would also apply for things like security or regulatory compliance. Now, if you'll permit me a small digression, the question comes up, is SRE a new name for DevOps? Is it a kind of DevOps? Do they compete? Are they in conflict? I think if you follow the team topologies model, there's a good answer for this, which is that DevOps is a platform team and SRE is an enabling team. The platform does provide some things that are reliability themed, such as mechanisms for automated rollbacks or canary releases. In practice at my company, this means that my team works closely with the platform team to increase safety in the various environments and help keep things working smoothly for the dev teams. So if you're going to build one of these SRE enabling teams, you can start with just one person, the smallest possible team, and this is the framework for that. This is the meat and potatoes. You're offering consulting services to other teams, and you're targeting them where and when they need it the most. You will meet with many teams for many purposes. A big part of your success hinges on knowing people, knowing what their responsibilities are, what they're working on, and you will act as a connector between these people. You know who needs to talk to whom. And you'll be a facilitator for these different types of meetings: SRE reviews, incident reviews, fire drills, game days. And you're not the boss. You're the helping hand. You can't actually make anyone cooperate with you. But if you're talking to developers who are on call for their own services, you have a built-in major advantage, which is that they like to sleep through the night. They care about reliability as much as you do. You can't be everywhere at once. You're only one person. That's what this is all about. So you use data to help you see where the reliability hot zones are and prioritize your actions and activities accordingly. So you'll scale yourself eventually with docs, tools, and automation, which will reduce your toil. And you're going to want to do this because you don't scale, at least not at first. So in the beginning, you're going to just have these meetings. You'll be face-to-face with these teams. At least you'll be on Zoom face-to-face. And it's time consuming, but you need to spend that time because you're developing your processes and your relationships. And once you've established how things ought to work, you've developed some rhythms, then you can systematize and standardize. You'll document your things and automate them, and then you'll begin to see scale. So the other reason this takes time is that you're shaping your culture. With some of the SRE things, you'll be asking teams to do things that may sound strange at first. So you need to have the empathy to understand how it sounds to them, and they're trying to preserve their time, and they want to know that their reliability really does stand to improve. So let's talk about some of these meetings that you'll facilitate. SRE reviews are like an architecture review through the resilience lens. So you start by opening up the architecture diagram and you take a look at it for failure modes. Every box on that diagram is a subsystem that can be slow or completely unavailable. And every line on the diagram is a potentially flaky network. We often design our systems for the happy path. You assume that the network is reliable. You assume that the database is always going to be there, that kind of thing. we ask our teams to enumerate every dependency, just put them in a table. And for every dependency, we say, what do you do if this dependency is slow? What's the behavior? What's the behavior if this is slow? What's the behavior if it's completely unavailable? Can you fall back to something else? Can you rely on stale data in a cache, for example? We also ask, as part of the review, that we prove that your alerting works as intended. And we do that by creating the conditions where your alerts would fire. And that's where the fire drills come in. So a fire drill is a chaos exercise that's focused down on a single microservice. And as teams learn how to do this, they become self-sufficient, which is one way that you scale yourself. You teach the teams, then the teams can go and do it. And here's the anatomy of a fire drill. You ensure traffic is flowing. You choose what kind of chaos you're going to trigger. You say what you think the behavior is going to be when this chaos happens. And then when the chaos happens, you monitor the service to see what the behavior is. And when it's done, there are often surprises. So you document the surprises and whether there are any remediations that you want to try to address them. Then there are game days, which don't happen as often. We're trying to do them. We're definitely doing them once a quarter. We're trying to do them, once a month. But this is a larger scale exercise. This is getting everybody on a call together, everybody who's operating in the test environment. And we're trying to introduce a platform-wide effect. So something bigger, like cutting off an entire availability zone is a good example. And like a fire drill, we're identifying weaknesses, places the system failed that we didn't expect it to, or that it should be able to survive. But another critical piece of running these is that it allows the people to practice responding to an incident. And it allows them to make sure they understand how these things work. Like, do you know who's on call? Can you find your playbooks when you need them? Do you have access? If you need SSH, does it work? Can you reach the bastion? That kind of thing. And it allows people to practice that getting the system back in service is the number one priority whenever there's an outage. There's no one recipe that works for every organization because everyone's in a different place along their process and technology maturity curve. So you meet your teams where they are. Everyone has to walk before they can run. And it's not a good idea to skip over steps. And informally, I kind of see the sequence as something like this. You have to have telemetry first. Once you have telemetry, you can have alerting. Once you have alerting, you can have on-call rotations. Once you have on-call rotations, you can have incident response procedures. If you've got that, then you can build out your post-incident reviews. Then you can do chaos engineering, and you can do service level objectives. So you can see some research on these practices in a report Google put out this year, SLO Adoption and Usage in Site Reliability Engineering by Julie McCoy and Nicole Forsgren. They interviewed a bunch of companies about their uses of SLOs, but they also asked about SRE practices in general. In the responses they got, you can see a kind of hierarchy emerge from the data. And this is interesting because you can see how your own company relates to what others in the industry are doing and using. And you can also see that there is a hierarchy at play. There is a sequence where these practices get adopted, and I think that's a helpful bit of guidance. So we talked about setting priorities and using data for this. We know about data. Data is oxygen for operations. It's the only way you know anything about what's happening in your system. Data also helps you prioritize. Alerting is the obvious case of this. If you get paged in the middle of the night, your priorities will realign immediately. But you can also use coarse-grained data to help you align your priorities. For every incident, you should be recording your time to detect, time to recover, and blast radius. Over time, you want to see those trending down and the time between incidents trending up. Now be aware that this is sparse data as incidents are relatively rare, but it'll still give you an impression of where your energy might best be spent. If you use microservices, another good way to set priorities is to look at the dependency graph of your services and put them into tiers. You can classify them according to how often they're on the critical path. And the more critical the service, the higher its availability needs to be. And that can give you an idea of how much attention these various services need from your SRE organization. Check out pager data for early signs of burnout. If there's a team that keeps getting woken up in the middle of the night, see if there's anything you can do to help. And SLOs are an advanced example of driving priorities with data. With a rigorous SLO, you can set a policy that service teams are only allowed to ship new features as long as they're meeting their service objectives. Your development teams have to trust you a lot to adopt something like this. But if they do, it means they're taking full ownership of their service's reliability. It also means you can start addressing problems before they become outages. And now, a brief interlude. And we're back. As the smallest possible SRE team, you'll want to create tools to amplify your effect. But because time is precious, you need the fastest and most pragmatic techniques available. You want to avoid getting sucked into a big application effort with a heavyweight application or UI framework. You can still get a ton of mileage out of good old shell scripts. Bash came out in 1989, and it's still one of the most useful things on your computer. I prefer fish shell myself, but whatever is near at hand is going to work fine. So the shell might seem old, but combined with the fact that we can reach APIs over the network from our command lines, our public cloud providers are putting this astonishing capability literally under our fingertips. And with tools like HTTPy and JQ, it means that any REST API becomes a command line tool. I mean, for better or for worse, JSON over HTTP, REST APIs are ubiquitous, and we can pull them down, mash them up, and do what we want. And because we're software engineers, if we need new APIs, we can add them ourselves. And if you're going to do that, go serverless. I'm going to mention some AWS technologies here, but this applies for any public cloud. Cloud computing is the quintessential tool for high leverage in our time, but even better if it's serverless. Because if my team is tiny, I can't afford to build anything that has a maintenance overhead. On the SRE team at Genesys, we love AWS Lambda because there's no packages to install or patches to apply. And we love DynamoDB, not because we have petabyte scale data, but because there is no maintenance whatsoever. I mean, I'm not getting paid to say this, but I can tell you DynamoDB just works. I can hardly think of anything else that I could say that about. Increasingly, we're turning to serverless publish and subscribe and event handling, and we're seeing really excellent returns on our investment from that. So here are 3 serverless SRE tools that we wrote with a very small team. Erebus is our chaos engine. And this, in very simple terms, is how it works. You invoke it with a service name, a chaos type, and a duration. It uses the AWS SDK to find all instances tagged with that name. It runs the specified chaos command using AWS Systems Manager. And it waits for the duration that you specified, and then it restores all the instances to normal. Having this tool is one of the things that allows our service teams to be self-sufficient with fire drills. They can run this themselves. Next up, we have Blacklight, which is an SRE auditing tool. And this allows us to do automated inspections of resources in our environment. We are listening for configuration change events. For those events, we run multiple rule definitions on them. And if the resource violates any of the rules, we notify the owners of the service. So to give you an idea of what kinds of rules we're running, we'll tell you if you're missing alerts that we think are the essential alerts. If you're using a deprecated availability zone, we'll notify you of that. And if you're using old versions of, say, a database engine or a Redis engine, we can notify you about that. One thing that's really cool about this tool is that you can add new rules to the system by adding new lambdas. Each rule is its own lambda. And that means we can ask for contributions from other teams to contribute rules. Okay, the third one I want to talk about is Oathkeeper. This is a new tool we have for doing service level objectives. We store SLI and SLO definitions in our database. The SLI definition includes a query. And for us, that would be either for New Relic or for CloudWatch metrics. And when we trigger an evaluation, it runs the query from the SLI. It compares the resulting data against the objective where we've set a threshold, and then it returns a report in JSON format. So remember, this slide has all the stuff on it that we need to care about. And of course, there are many talks and resources about every one of these things, and I don't have enough time here to go into them all, but I do want to focus a bit more on two of these: post-incident reviews and chaos engineering. So incident reviews are a wealth of information about what SRE could be focusing on next. We do these once a week at Genesys, and it's a very important way for the organization to learn from these incidents. If you're not doing incident reviews, you should be doing them, but if you are doing them, it's always possible to get better at this. I highly recommend you go watch this talk. This is John Allspaw from DevOps Enterprise Summit in 2017. This is called How Your Systems Keep Running Day After Day. And he makes some really good points in this talk. He talks about how we all need to form mental models of how the system works. There's no one mental model that works for everyone. Everyone needs to formulate their own mental models, and we constantly need to update them to improve their accuracy and fidelity. And the other thing he talks about is how if you're doing an incident review, it's not about just getting to the action items. It's about the process of learning, about discovering things you didn't realize about how the system behaves. And as I said, we can all improve this process, and that's part of your job if you're running SRE. About chaos engineering, this is one of those things in SRE that's tremendously useful, and initially it's quite counterintuitive. You mean to tell me you're going to break things on purpose in the interest of reliability? It can be a tough pill to swallow, right? But one of the truest things about reliability engineering is that when you take a close look at the behavior of a complex system, it almost always surprises you. Chaos engineering is so useful because how we think our systems will behave under duress is almost never how they actually behave. And you want to learn about that in a safe way, under controlled conditions, and not at 3 o'clock in the morning with alarms blaring. So yes, you should be doing this widely in your organization, but there are a couple of mistakes that are easy to make, and I would like you to avoid them. First, do not scorch the earth. Your mission is not to show that you know how to burn everything to the ground. The right amount of chaos is just enough to expose some turbulence in the system, something you can actually address with some remediation. Especially go easy at the beginning, because you're trying to convince people that this is a worthwhile thing to do. Second, the chaos must evolve as the system evolves. As you build up resilience, the chaos that used to make fireworks becomes a boring non-event. That's wonderful because it means it's working. Just don't forget to move on to the next thing. Turn up the heat a little bit when you need to. A side note about chaos engineering in serverless applications. We've been encouraging our dev teams to adopt serverless designs, but our mature tools for chaos engineering are made for machine instances because we can get onto the instances and make bad things happen. While there are options for Lambda chaos, we don't love the ones that require a dev to include a special library or code against a wrapper API. Things are moving fast in this area, and we'll be keeping our eyes on it. Just as the pen is mightier than the sword, it is also mightier than a bunch of meetings. You want your teams to always be learning new ways to improve reliability, and you want SRE topics to be percolating regularly in their minds. There's never enough time to have all the conversations you could want to have, so writing is tremendously powerful for this. You could write a tech blog, and that's fine, but everyone is so busy that a blog is easy to overlook. We like a format we call the SRE Minute. It's a very short, very practical article about SRE sent out in an email every couple of weeks to the whole development organization. It's important that it's short because it increases the chances that your audience will open it. And it's important that it's pragmatic because then you're building your reputation for not wasting people's time. Once you get this going, you can get volunteers to submit new ones for you. And then we're on the track to scaling ourselves again. Speaking more generally, writing is maybe the highest leverage tool you have. In your documentation, your meeting agendas, and even ordinary email, you're constructing a framework that enables others to follow. And if you succeed, you might not remain the smallest possible SRE team. Maybe you'll get to hire some people. We started by offering SRE rotations so developers could try out the SRE thing for a quarter. And then 100% of those rotations became full-time members of the team. Since other team leads are getting wise to this, we probably can't get away with this very much longer. But if you get more people, you can afford to build UIs. You can create a real training program. You could continue to use the enabling team format, but the topology isn't fixed. One of the salient points in the team topologies book is that since our systems are dynamic and adaptive, our team structures should be as well. So you could consider embedding SREs onto individual teams. And you could even create a more specialized form of the platform team that's just for SRE matters. We haven't done this yet, but it's something that we're seriously looking toward since we see some platform capabilities that really do need to be the purview of SRE, things like observability and alerting. And so we'll be looking at trying this out in the near future. And that's all I have for today. Good luck in your endeavors. My parting thought is there is no destination. It's all about the journey. Thank you.